Hi, let's continue our discussion on treating multicollinearity. By the end of this video, you will be able to treat multicollinearity using VIF. In the previous video, we checked for multicollinearity in our dataset. Now the next task would be to remove the variables from the pairs to avoid the multicollinearity. But how do we do that? For that, we will be using the variance inflation factor, that is VIF, as criteria which we learnt in the previous tutorial. To calculate the VIF of our independent variables, we will start by importing the necessary library. As VIF is a concept from statistics, we will import the variance inflation factor function from the stats.outlierInfluence module of the stats models library. Next, we are creating a copy of the X and naming it as VIF_data. Now, instead of calculating VIF for just one independent variable, we will calculate VIF for every independent variable using list comprehension and store it in the form of pandas.series. If you look closely at this line of code, it is basically a list comprehension inside a pd.series function. The red box represents the pd.series function and the green box inside represents the list comprehension. As we discussed in this tutorial, the syntax of the list comprehension is result equal to element of final list into how to take different values into condition to store the final element. The element of the final list in this case is a value which is returned by the function variance inflation factor. This function takes two values as input, which are the VIF data and the index of the column in that data to calculate the VIF factor for, as represented by the variable I. Obviously, you might have guessed the range of values for I. It is from 0 to the number of columns in the data as represented by the range VIF_data.shape 1. Now getting back to the complete statement, we are storing the resultant list of values in a pandas.series named as VIF. We are also indexing each value of VIF with its corresponding independent variable name as shown in index equal to VIF_data.columns. So let's run this cell and look over the results. You can clearly see that there are a few variables which have their VIF over the threshold of 5 and need to be removed. But did you notice something? Earlier, we inferred that there are 16 pairs of independent variables with high correlation. But when we calculated the VIF factor, only 7 variables are actually exhibiting the multicollinearity. It is because the correlation was calculated between a pair of independent variables, whereas the VIF is calculated using all the other independent variables. So let's remove all of them, should we? If you remember, removing only one variable from pair of correlated independent variables was enough. Considering this fact, if we remove one variable, there is a good chance that the VIF of other variables will go down. So, to remove multicollinearity while removing as few variables as possible, we need to follow an iterative process where we calculate VIF of all the variables and then eliminate the one with the highest VIF value, and then again calculate the VIF of all the remaining input variables and eliminate the highest VIF value, and repeat this process until there is no input variable left whose VIF value is above 5. Being a Python programmer, we will try to automate this task. We know that we are storing the VIF values in pandas series. So let's see how that is useful. Here we use the pandas.series name and mention the max value as the condition. We have already seen this before, but we add .index0 at the last. What it will do is that instead of returning the max value of the VIF in series, it will return the index where the max value is stored. So let's run this cell. This is exactly what we needed. By knowing the name of the independent variables for which the VIF is maximum, we can remove that variable from the dataset. So let's do this. We define a function MC_remover to solve the issue of multicollinearity. This function simply takes the data from which the multicollinearity is to be removed. For this, we start by calculating the VIF of all the variables in the data as we did before. Next, we have written a conditional statement where we are checking whether the max entry in the VIF series has a value greater than 5. If the condition is true, we will be printing the column which has been removed and then drop the column corresponding to the max value in the VIF series and then return a modified data. If there is no VIF value greater than 5 present, then I will simply print no multicollinearity present anymore and return the final data. So let's run this cell. Nice, the cell ran without any errors. So let's use this function to remove the multicollinearity from our data. Earlier we estimated that there are 7 independent variables exhibiting multicollinearity and VIF value for all the independent variables in the remaining dataset is less than 5. Hence, we know that we need to run MC_remover function at most 7 times for all the independent variables exhibiting multicollinearity to be dropped, though in reality, as I keep removing variables iteratively, VIF of other variables may reduce to less than 5 and hence they may not need to be removed. So we run MC_remover function in a loop 7 times and pass VIF_data as its parameter. The modified data that the function will return will update the actual VIF_data. In a sense, we update the VIF_data by iterative removal of the independent variables with VIF value over 5. So let's run this cell and observe the modified data. Alright, so we were able to remove the multicollinearity within the 2 iterations, as we can clearly see that flat area and condition of the house fair have been removed and no multicollinearity present anymore as the output 5 times. So let's check the columns that survived the removal of the collinear independent variables. We can see that the number of independent variables has reduced to 28 from earlier 30, and none of the remaining variables have the VIF value over 5. So the problem of multicollinearity has been solved. In the next tutorial, we will focus on training our model.